Okay, welcome everyone. This is the week 4 webinar. And why is it important that 4 is an even number? Why do we care? Yeah, it's exam week. So don't forget that this week we will have our week 4 exam. And again, the exams are a lot of points. The assignments are not that much. The exams are a lot of points. So, make sure you get that ready and, practice a lot and then go and do it. And let me tell you the plan for this webinar. I'll start out as always with Q&A and I'll answer any questions you have throughout the whole webinar. And then after that, we're really going to focus on the normal distribution. I mentioned that that is the most important distribution of all distributions by far. I'm not biased. Everyone agrees with that, every statistician at least. So we'll talk about what's called the standard normal distribution, which is like the easiest normal distribution. And do a little review and calculate probabilities and percentiles if you're at the standard normal distribution. Then we'll get into the general normal distribution. So that's going to have to do with, you might have some different mean and standard deviation than the standard normal distribution. That's the main thing. And then what we'll do is we'll calculate probabilities and percentiles when you're given a general normal distribution. And we will be using the calculator for that. In fact, there's no way you can do it without a calculator. It's just isn't going to happen, or at least most of you. And then we'll get into applications. But we're only going to do some applications. They're not quite as important as the ones we're going to be doing later. Next week is the big week to really, really understand why the normal distribution is the most important distribution. This week we'll have a couple applications, but again, it's assumptions are made and stuff like that. But we'll next week we'll really understand why statistics is all about the normal distribution. So that is the plan. And I want to remind you that a week from Sunday, what big thing is due? Yeah, Project 1. And again, don't wait until the last minute on that. That'll be a disaster. So the idea at this point, you hopefully have collected your data. Because the idea is if you collected your data by now, then you can spend a week or so writing your project, at least a draft of your project. And then maybe a week from today, you can send me your project draft. I'll take a look at it. I'll give you lots of suggestions for improvement. And then you'll have several days to improve on it and then submit it. So that's the idea. If you don't send it to me, I don't like take off points if you don't send it to me. But what happens if you don't send it to me, then I can't look at it in advance and let you know what's wrong with it and where it's missing stuff so that you can fix it so that you don't lose points because of what was wrong. So that's the idea. So again, make sure you have that timeline set that you should be, really getting your project worked on. So that a week from today or tomorrow is what I recommend. You can send it to me. The absolute last time to send it to me is a week from Thursday morning at 8. But again, I read it on a first sent, first read thing. So yeah, the rest of you, can you hear me and everything? I just want to make sure. We just lost someone because of audio issues. I want to make sure that it's not my side. So can you guys hear? Can you all hear me? Loud and clear. Good, good, good. I just want to make sure it's not me, because again, I don't know if you hear me, because I hear myself, but that's nothing to do with technology. That's my ears and my voice. But okay, so anyway, that's the plan for today, and I want to let you know this is one of the easier weeks in terms of the material that we're doing, because what I want you to do is really focus on the project. That's the hope, is that this week is a week to really push the project. And this is, you still have stuff to do. You still have, an assignment, and you have the discussion post. The discussion post is one of the easier ones. And I do want to let you know, do you remember last week I said, here's some words you have to use to get full credit on the expected value? And if you don't use those rules, words, I take off points. Do you remember me saying that? Hopefully you remember, because I did say it. I said it really loudly, in fact, just to make sure. Unfortunately, I'd say more than half the class didn't use those words and lost points. And I don't know what else I can do. Pay attention to the webinar. If I say you have to use these words, you have to use these words, okay? And that's going to happen, not necessarily so much today, but it's definitely going to happen, from time to time. All right, so what I want to do, who remembers the empirical rule? That got talked about a little while ago, a couple weeks ago. Anyone remember the empirical rule? Let's see how jumping in. Empirical rule is actually important for your project because that's how you decide, you look to see if you have a normal distribution, you can use the empirical rule. And if you don't have a normal distribution, then you can't use the empirical rule, okay, or at least approximately normal. So that had to do with the normal distribution. So that's why I'm reminding you about the empirical rule, because I want to go over that again. So here is a picture of the empirical rule. So if you have a normal distribution, you'll notice a normal distribution it's symmetric about the mean. It's just unimodal, so there's just one lump. And then, so there's a high point in the middle. It's smooth, curved, and then it goes down and then falls down pretty quickly and then never goes below zero. That can't happen with probabilities, it turns out. You can't have a negative probability. But that's the normal distribution curve's shape. It looks like this. And what the empirical rule says is that if you're within one standard deviation, there's a 68% chance approximately of being within one standard deviation. There's a 95% chance approximately of being within two standard deviations. And there's a 99.7% chance of being within three standard deviations. Do y'all remember that happening? It's really important. Sometimes they call it the 68, 95, 99.7 rule. I've heard that one too, but more people call it the empirical rule. Okay, any questions? Any questions on that rule? All right, so just to note, to make it a little easier, if you have a normal distribution with mean 0 and standard deviation 1, then you can draw this picture where you have 0 right in the middle, and then you have -1 to 1 on the, usually we call it the z-axis if it's 0 for the mean and 1 for the standard deviation. And then it's 68% between -1 and 1 on the z-axis. And then we have a -2 to 2 is 95%, -3 to 3 is 99.7%. Notice once you get down to -3 and to 3, you get almost all of it. 99.7 is just about everything. Any questions about the empirical rule? Okay, so now we want to use it. So we're going to take a look at the empirical rule, and we're going to look at some questions. Okay, so suppose that Z follows a standard normal distribution. When you say standard, that means the mean is 0 and the standard deviation is 1, because those are the easiest numbers that can happen. We call that a standard normal distribution. Normal means it's this bell-shaped, unimodal, symmetric curve. And we want to use the empirical rule for the following. So the first question is, find the probability that Z is between -1 and 1. So just to note, this is a reminder from last week. Remember last week we looked at the kind of symbols you use to talk about the distribution? Here, if we have a standard normal distribution, the variable is always going to be z. And we'll see that in a little bit why. And then if you remember, this tilde means has the distribution of. What does n stand for? See if you can put in your chat box what n stands for. What does n stand for? Talked about this last week, actually. I don't see y'all jumping in, but you should be typing in your chat box. What does n stand for? I don't see you jumping in. It's not a trick question. The size of the population, that's in some other cases, but not when you're talking about a distribution. It's a good try. It's a good try. Remember, if it was a U, we would say uniform. Do you remember that? Any guess on what the N is? It's not uniform, because uniform doesn't start with the N. Any question? Any thoughts? Should be obvious. Let's see. N stands for normal. So that's really important to know. We have a normal distribution, so we say z tilde n. The first number here represents the mean, and the second number here represents the standard deviation. So when we have a standard normal distribution, that means that our distribution is normal with mean 0 and standard deviation 1. Any questions on this idea? Okay, so now the question is, what is the probability that z is between -1 and 1? Let's see if you can put in the chat box the answer to this. And the hope is it's very easy. We'll do some harder ones, but this one's the easy one. What's the probability that z is between -1 and 1? Yeah, 68%. And I'm going to write it in decimals because that's more likely what you're going to have to do on assignments. And that's 0.68. Any questions on finding the probability that z is between -1 and 1? And that comes right from the empirical rule. You go from -1 to 1, that's this area. And this area says 68%. Any questions on that? Okay, so now let's look at the next question. What is the probability that z is less than 3? That one's going to be harder. That one's going to be harder. You're not just going to be able to write down a number that you read. So the first thing you can do is you can look at the picture. Here's 3. And you want the probability that we're less than 3. So that means to the left of the number 3. That's all this area. All right, we don't know all the area right away, but we know between -3 and 3. How much area is between -3 and 3? What's the probability of being between -3 and 3? Yeah, 99.7% or 0.997. So what we can do is we can split this up. We can say, well, we're going to go all the way far left to -3. And then we're going to add -3 to 3. So let's do that. That's the probability that z is less than -3 plus the probability that -3 is less than z is less than 3. Because it's area and you just cut it in 2 pieces and add up the areas. Any questions on that idea? Okay, so the second one is easy. That's the, oh, leave some space. That's going to be the second one is going to be 0.997. Probability that z is less than -3. That's this part here. Okay, the idea is if 0.997 is between 3 and -3 and 3 inside, how much is outside? If inside between -3 and 3 is 0.997, how much is outside that area between -3 and 3? Remember how to do that? It's not that hard. Thoughts? See you all jumping in. So the key is to remember that the entire area has to equal 1, right? The probability of the universe is always 1. So if the inside is 0.997, the outside is 1 minus 0.997. Any questions on that? Okay, we don't want the whole outside. We just want the left. So if we know the left and the right is 1 minus 0.997, and we want just the left, and we know it's symmetric, what do we do to get just the left? Any thoughts? Yeah, divide by 2. Because if the left and the right are 1 minus 0.997, then the left only is 1/2 of 1 minus 0.997. So that'll be 1/2 times 1 minus 0.997. Any questions so far? Okay. And then sticking a calculator, 1 minus 0.997 is 0.003. 1/2 of that is 0.0015 plus 0.997 is equal to 0.9985. You're always welcome to use a calculator for those kind of things. Any questions on part B? All right. So let's do part C. Find the probability that z lies between -1 and 2. So that's the probability that z is greater than -1 and less than 2. So the idea here is, so we want in the picture from -1 to 2. Well, we know from -1 to 1, that we already figured out. That was 0.68. So that's going to be equal to the probability that -1 is less than z is less than 1. And then plus the probability that 1 is less than z is less than 2. Any questions on how I broke it into 2 pieces? From -1 to 1 plus 1 to 2 will give you -1 to 2. So probability that z is between -1 and 1, we already found that out. That was 0.68. Now we want between -1 and 2. So we know between -2 and 2, it is 95% or 0.95. Between -1 and 1 is 68% or 0.68. So if we want these 2 pieces combined, these outer pieces, then we can subtract 0.95 minus 0.68. That'll give you the 2 pieces. If we want just 1 piece, just like before, you divide by 2. So that's plus 1/2 times 0.95 minus 0.68. 0.68. Any questions on that? Any questions? Is that clear? Okay. And again, you can put it in a calculator. Maybe I'll do that for you. 0.68 minus 1/2 times 0.95 minus 0.68. And our Google calculator gives you 0.239. Any questions on that? Is that clear? Did I lose anyone through the math? A little bit of math there. Nothing too intense, so. All right, now let's do this one. Find the z value such that there's a 2.5% probability of being greater than this z value. Any questions on the question? Okay, by the way, if there's a 2.5% probability of being greater than the z value, is this going to be a large z value or a small z value? It's going to be on the left side or the right side? Yeah, it's going to be on the right side. If only 2.5% of people are taller than you, you're tall. Is that clear? So that's one thing to note, that we're on the right-hand side somewhere out here. So if there's a 2.5% probability of being greater than the z value, the key is we can look at the right-hand side is 2.5%, but then what we can do is we can take the mirror image and say there's 2.5% on the left side of the mirror image of that. What's 2.5% plus 2.5%? %5, yeah. Okay, so that means the outsides have a total of 5%. How much is the inside? If the outside has a total of 5%, how much is in the inside? Supposed to be easy. Yeah, 95%. So it's going to be 1 minus 0.05, which is equal to 0.95, or 95%. So now we can use the empirical rule. What must the value of z be based on this 95%? So what must z be? Should be really easy. That's a hint. Let's see you all jumping in. Okay, if we look at this, if you see this 95% here, and we're on the right side, what's the value for z? Right? If we're on the right-hand side, that value of z is 2. Yeah. And that's the answer. Any questions on this question? see, yeah, I can get this one done. What is the 16th percentile? Well, we do the same thing. What does it mean to be the 16th percentile? You remember? So it means the area to the left of Z is 0.16. So we do the same idea. If the left, so if the area to the left is 0.16, are we far left or far right? Are we on this side on the left, or are we on this side on the right? If the area to the left is 0.16. Yeah, we're on the left-hand side. That's important to note. We're going to be, so that means our answer is going to be negative. Now, if the area to the left is 0.16, what we can do is we can look at the mirror image and say the right tail is also 0.16. So the outside is 0.16 plus 0.16, which is equal to 0.32. So the inside, do the same thing, is Z equals, is 1 minus. So the inside area is what I want, is 1 minus 0.32, and that's 0.68. So what is Z? Yeah, Z is -1. Any questions on that? Okay, then the last one of these is, let's say Z is 1.3. Let's see if you can find the Z-score. And the hope is you don't even need a calculator. You need to do some work, but you don't need a calculator. Tell me what the Z-score is if Z is 1.3. And remember, the hint is, the formula for Z is X minus mu divided by sigma. And so what will the Z-score be? See if you can put in the chat box the answer. What's the Z-score? We start as Z is 1.3, and we do the calculation. So X is 1.3 minus mu. Well, for the standard normal distribution, mu is 0. And we divide by the standard deviation, and for standard normal curve, standard deviation is 1. What is 1.3 minus 0 divided by 1? The hope is you don't need a calculator for this. You should just be able to do it in your head. See y'all jumping in. It is important you paying attention. There you go, 1.3. Because 1.3 minus 0 is 1.3. 1.3 divided by 1 is 1.3. So notice nothing changes. We start with 1.3, you get 1.3. That's true of any number you do. So that's why we use the letter Z for the standard normal distribution, because calculate the Z-score, you get the same number. Any questions at all on the standard normal distribution with the empirical rule? Any questions? Okay, if there's no questions, we're going to move on. Now we're going to look at something a little different. Let's suppose that X follows a normal distribution with mean 114 and standard deviation 23. So what we can do is we can write in symbols X tilde N, 114 comma 23. And we want to find the probability that X is between 100 and 120. All right, so I'm going to let you know, if you remember, probability was area under a curve, right? Okay. Now, if you don't have nice numbers like this -1 and 1, finding an area here is not easy if you wanted to like do it in your head or by hand. There's no way you would even have a chance of getting the area without a whole year of calculus. Who's had a whole year of calculus? Say, I've had it. So yes, if you've had a whole year of calculus, or no, if you haven't. And my guess is nobody. I have. I mean, I've had lots of math. I can do it. But so what you're going to have to do is we're not going to be able to do what we just did. You're not going to be able to do these calculations because it is brutal. Even, and by the way, if you had a whole year calculus, you would be convinced that you don't want to do the calculations because they're really hard, even if you know calculus. So that's not what we're going to do. Any guess on how we're going to calculate this probability? Any thoughts? What's our strategy for calculating this probability? Any ideas? See y'all jumping in. All right, if you don't answer, I'll tell you, but I hope as you know by now what you need to do. If it's that hard, if you need calculus, you go to the calculator. Okay, you go to this calculator that I created for this course because it makes it much easier to do everything. Okay, don't use equations and formulas and all that stuff. Just jump to the calculator. Which calculator number do you think we're going to need to use? Because that is important to know which calculator. Thoughts? Should be obvious. You can put in the chat box. So what calculator are we going to use? Let's see, jumping in. What have we been doing the whole time? We've been finding the probability that involves normal curve or normal distribution. So we're going to use normal probability. Number 8. Any questions on that? Any questions? And then we wait for the internet to make it happen. There it is. So it says fill in all the values except one below and hit calculate. Then the last value will be given to you. So it asks for low, high, mean, standard deviation, and P for probability. And you're going to let one be blank and you're going to plug the others in. So do we know the low? And if we do, what is it? If we want the probability that X is between 100 and 120, do we know the low? Not a trick question. See y'all jumping in, but hopefully, especially those who haven't been posting at all on the chat box, you can, it's helpful for you to remember things too if you do that. What's the low? What's the smallest number such that x is between 100 and 120? Not a trick question, should be really easy. Let's see, jumping in, the smallest number to be between 100 and 120 is 100. Any questions on that? The high is the largest number to be between 100 and 120, and that'll be 120. The mean is 114. The standard deviation is 23. We are asked to find the probability. So P equals, that's the one you leave blank. So we have 100, 120, 114, 23. Any questions on that? And I hit calculate. And there's the probability. The probability is about 0.3315 or so. It also shows you the picture. I did that actually over winter break, is I coded it so it actually shows the picture of what's going on throughout this whole calculator for all the rest of them actually. And there's our probability, 0.3315 about. Okay, how many decimals, you can do more if you wanted. Whatever it tells you on the homework assignment, it usually tells you. Any questions on that? And there's our probability, 0.3315. Okay, now comes a little bit messier. What if you want the probability that x is greater than 200? What's the lowest number greater than if x is greater than 200? What's the bottom? What's holding the bottom? Let's see, all jumping in. Not unknown. It's 200. Because as soon as you hit 200, everything else is greater than that. Do you see? So the highest number you can be so that everything else is greater than you is 200. If you want to be greater than 200. Now comes a little bit tougher one. What's the highest number that's greater than 200? You know what that is? I don't see y'all jumping in, but it's infinity. And the problem is computers can't handle infinity well. So here's what you do. If we go back to a picture, yeah, it's infinity, but if you go like way over here, there's not much area left to the right of it. Do you see that? So you just have to make sure you're really high. And what I recommend doing is looking at all the numbers that are given in the question. Look at how many digits there are. The biggest number of digits is 3-digit numbers. So then what you can do is add 2 of that and make 5 nines. So 99,999 is so much bigger than everything else that that'll be counted as infinity for the calculator. That'll be good enough for as many decimals as you would ever dream of needing. Any questions on that? The mean's not changing, 114. The standard deviation is 23. And P, we want the probability, so that's what we don't know. So now we just go and do it. So again, the low, was 200, remember? The high was a whole bunch of nines. Okay, more nines, a couple more nines than any of the other numbers even have numbers of digits. Same mean, same standard deviation. We don't know P, so I leave that blank and I hit calculate. It's actually a very small number, 0.00009233. Really tiny probability. At 9233. Any questions on that? Okay, the next one is let's find the probability that x is less than 90. So same idea is the low, though, to be less than 90. Is there a lowest number that's less than 90? What do you think? What's the lowest number less than 90? Don't see y'all jumping in. The idea is if you just say less than 90, you could be as low as there is, and that's negative infinity. So you apply the same little computer trick is you say, well, 3 digits, so I'm going to go negative, and then put in 5 nines. The high will be 90 because that is the border of the numbers less than 90. Same mean and standard deviation, 114 and 23. And again, we don't know P, so we leave that blank. So we plug in negative bunch of nines, 90. Same mean, same standard deviation. Get rid of the P and hit calculate. Got 0.14836 or 0.1484 according to the picture. Any questions? Any questions on this example? Okay, so part D is find the probability that x is greater than 105, and then given that x is less than 125. So this is hard for a lot of people because they forget chapter 3. This uses chapter 3. When you have a given, you can use a formula that says that the probability of A given B is equal to the probability of A and B divided by the probability of B. To be greater than 105 and less than 125 means you're between 105 and 125. So it's the probability that x is between 105 and 125 divided by the probability of B, or the probability that x is less than 125. So to do that, we're going to need 2 different numbers. We're going to have to use a calculator twice. So we're going to have a fraction. And let's do the first one, 105 to 125. Same mean and standard deviation. P-value is blank. And it's 0.3360. For the probability that x is less than 125, then 125 will be the high. The low will be negative infinity or negative a bunch of nines. Same mean standard deviation. And I calculate and I get 0.6838. Any questions on that? I can hit scientific calculator. And again, we had 0.3360 divided by 0.6838. And that is about 49137. So 4914. Any questions on this example? Okay, so the next one is let's find the IQR. Now, hopefully you remember IQR is the interquartile range, which is Q3 minus Q1. Q3 means that you have 75% below that value. So now we know the percent below the value, that's the area to the left. There's our P, is 0.75. If it's below that value, it could go very, very far below, which means negative infinity, that's your low. That value is what we don't know, so we leave the high blank. So now I go to my calculator. High is blank. P is 0.75. Same mean and standard deviation. I hit calculate. And I get 125.51. Any questions so far? Similarly, for the first quartile, Q1, the same idea, but now 25% is below the value. So the low is still negative 9999. The high is the value. We don't know. Same mean, same standard deviation. And now P is 0.25. So I'm going to take that 0.75, make it a 0.25. The high I want to leave blank. And hit calculate. And you get 98.49. Any questions so far? So now we just subtract. We have 125.51 minus 98.49. That you can just drop in a basic calculator, 125.51 minus 98.49. And you get 27.02. And that's the IQR. Let me stop. Any questions on finding the IQR? A lot of geometry, kind of looking at the picture. All right, let's do the next one is the middle 84% of the data is between what two values? Any questions on the question so far? Okay, so the idea is that the middle 84% is between what two values? If 84% is inside, how much is outside? Because we can't leave two values blank. So let's go for the outside. How much is, if 84% is inside, how much is outside? Yeah, so 16% is outside. If 16% is outside, how much is to the left? Yeah, 8%. So 8% is the left tail. So if 8% is the left tail, that means P is 0.08. We know the low is negative infinity. The high is what we don't know, same mean and standard deviation. We calculate, you get 81.68 about. Okay, we could do the same idea for the right tail. So if 8% is on the left, that's the value to mark the left, then the right will be 92%, 1 minus 8%. So now we go ahead and instead of 8%, you go 0.92. We don't know the high, we leave that blank, that's what we want. Hit calculate, you get 146.32. Okay. So those are the two values. The low value will be 81.68. The high value will be 146.32. Any questions on that example? Any questions? All right, then this will be easy actually. Find the z-score for the value of 117. So for this one, we don't even need a fancy calculator. I'm just going to use a scientific calculator. And if you remember, z is x minus mu over sigma. X was 117 minus mu. Mu was 114. We divide by sigma. Sigma is 23. So you get 0.1304. That's your z-score. If I'm going too fast, let me know, because you're all being kind of quiet. Any questions on kind of the idea of part G? Because that's going to be the last one of the just mathy looking ones. Any questions? All right. Are we ready for an application? So here's the application. All right. So suppose at the time until you or your wife, if you're male, will give birth. Okay, so you're pregnant. You're going to be giving birth. And let's suppose that that amount of time is normally distributed with mean 140 days and standard deviation 7 days. Just a note, kind of in like, if you want to talk to someone who doesn't understand any statistics, what would you say about this 140 days? What would that tell you? How do you say that in English, like non-math English? You've all heard these words. Has to do with giving birth, being pregnant. See y'all jumping in. Okay, let me explain then. Okay, if someone says, when are you expecting? That's what that 140 would represent. It is your mean amount of time to have the baby between now and birth. And that is the when are you expecting? It turns out that it used to be the standard deviation was 7 days. It's not anymore. I'm not sure y'all who's in the room, any of you know about this stuff at all? And anyone know why it's not 7 days anymore? 150 years ago, standard deviation was 7 days. But it's not anymore. This isn't math, this is science. This is history and science. But it's, medical. Let's see y'all jumping in. Okay. Nowadays, someone is pregnant and they're very pregnant and they're way overdue, the doctor goes in and just does a C-section. So what's happened is because of doctors, and by the way, doctors are good, not bad. This isn't a bad thing. Doctors give C-sections. And so it's not quite beautifully normal with the Beadle standard deviation, but if it's a natural birth, it actually is. And it's really approximately normal, and the standard deviation really is 7 days. So I figured I should let you know this is real, okay? But without medical stuff. So the distribution will be X tilde N 140,7. Okay, so now here is the scenario. Okay, so your boss, you got a job, and your boss has just scheduled you or your wife for a business trip out of the country. So whoever's pregnant is going to have to go out of the country on a business trip. You or your wife leave today and will return in 135 days. Find the probability that your baby will be born out of the country. Is that clear? Any questions on this question? What's the probability your baby is going to be born out of the country? So again, we have a normal distribution. If the baby's born out of the country, what is the low? What's the low? You're leaving today and you're going to return in 135 days. So what's the low? Let's see y'all jumping in. The low is 0. 0 days from today because you're leaving. Any questions on that? What's the high? The most number of days before you have your baby so that it's still born out of the country. Yeah, 135. What's the mean? $140. And what's SD, the standard deviation? Yeah, 7. P is what we don't know. That's what we want to find out. So 0, 135, 140, and 7. 0, 135, 140, 7. So low is 0, high is 135, mean is 140, standard deviation is 7. P is what we don't know. We leave that blank. And we calculate. 0.2375. Okay. By the way, let's suppose that you really want, you're hoping in the future that your baby will someday become president of the United States. Are you going to be okay if there's a 23.75% chance the baby's born out of the country? Would you be fine with that? Okay, I hope not. Okay, I use the example of president because I don't know if you know, but you have to be born in the United States to be president of the United States. That's one of the rules. Okay, so it's probably not good. So here's part B. You decide that it's too risky. Okay, so you're going to negotiate with your boss. That's how things work, right? To ensure that there is no more than a 1% chance that baby will be born out of the country. What day should you ask to be the return date. You're not okay with returning in 135 days. You're going to have to return earlier, so it's a much smaller probability. How do we decide what day? So we need a probability again. What's the low? What's the low? Yeah, 0. 0, because you're still okay leaving now, because just starting being pregnant, you're not going to have the baby now. Do we know the high? Right? High is a return date. Do we know the high? What do you think? Yeah, let's see jumping in. The idea is, the question is, what is the return date? That's what we don't know, which is the high, and that's the question mark. We don't know. The mean, still 140. Standard deviation is still 7. What is P? Yeah, 0.01, because that is the probability of 1%. So then we can have the low as 0, the high we're going to leave blank. Same mean, same standard deviation. P now is 0.01. And I hit calculate. And 123.72. And if you're going to negotiate, you're probably going to say, this is one of those you're probably going to round down because you're negotiating with your boss and say, don't make me return that late. I'm returning in 123 days. Any questions on this example? Clear? Okay, part C is, it is now 138 days later, and the baby has still not been born. Okay, so you're back in America. Okay, back in America, it's 138 days later, because remember, you returned in a day 123. And still pregnant. Either you're pregnant or your wife is pregnant. Find the probability the baby will be born in the next 24 hours. So to do this one, this is a conditional probability. So if it's born in the next 24 hours, that means it's born between day 138 and day 139. So that means that the probability that X is between 138 and 139. But we're given that the baby hasn't been born yet, and it's day 138. So X is at least 138. Any questions on that? So X is at least 138. So when you have a given probability like this, we can use the rule of conditional probability and say that's the probability of A and B divided by the probability of B. Now, if you're told that the baby is born sometime between day 138 and 139, and it's at least 138, that's still the same thing as 138 to 139. So the and greater than 138 doesn't tell you anything new. So it's still the probability that X is between 138 and 139. And then we're dividing by the probability of B, which is X is greater than 138. Any questions on that? So that's going to be a fraction. We want 138 to 139. So the low is 138. The high is 139. Same mean, same standard deviation. We don't know the probability. Leave it blank. We calculate. 0.05565. To be greater than 138, that means the low is 138. The high will be basically infinity, a bunch of nines. And we find the probability. And that's 0.61245. Any questions on that? Any questions? Okay, and then 0.565. Divided by 0.61245. Oops, I lost. I have to erase. There we go. One more time. It's 645. I'm trying to remember. 0.5565. 0.5565 divided by 0.61245. So about a 9% chance. Any questions on this calculation? I like this application. It's kind of fun, somewhat real. Let's do one more calculation. It is spring and it's getting warmer. So let's suppose you have a new business and you're selling ice cream. Sound like a good business? Okay. And let's suppose the amount of ice cream that you sell each day is normally distributed with mean 950 ounces and standard deviation 120 ounces. So we can write x tilde n 950 120. Okay. And by the way, in business, it's really important to do the research and see what your mean and standard deviation are, and that'll help you make decisions in business. So let's find the probability that on a randomly selected day, you're going to sell between 900 and 1,000 ounces of ice cream. It's good to know, what's your business going to do that day. So the low will be 900. The high will be 1,000. The mean will be 950. And the standard deviation be 120. And we want the probability. So we do the same thing. I'm going to hit refresh because that just erases everything because we're on a new problem. But we still need a normal distribution. And the low, we had 900 to 1,000. The mean again, 950. Standard deviation was 120. And there's our probability. 0.3231 about. Around a 32% chance. Any questions? Any questions on this example? Okay, let's look at another one. Say, same ice cream store. In the morning, you took stock of your supplies and noticed that you have 1,100 ounces of ice cream in your store. What's the probability you're going to run out by the end of the day? Because that's really important. Because if you're going to run out by the end of the day, you can't, especially if it's a nice, hot, sunny day, and you're going to tell people, I'm sorry, we're an ice cream shop, but we ran out of ice cream. They're not going to be happy about that. And your business is going to have troubles. And you're not going to make profit because no one's going to buy ice cream from you because you don't have ice cream to sell. So you want to find out this probability. If it's like 1 in a million chance, you're going to say no problem. If it was, say, 75% chance, you go, oh, that's terrible. Any questions on the idea here? This is why you care. All right, so in this case, what is the low? What's the lowest amount? What's the kind of lower boundary of running out of ice cream in terms of the demand? What number should the low be? Maybe you can put in the chat box. What's the low? If you can put in the chat box, what's the low? What's the lowest amount, kind of the lower bound of running out? Don't see jumping in. So the idea is if you have 1,100 ounces of ice cream, then if you end up selling 1,100 ounces of ice cream, you just ran out. Anything lower than that, you still have ice cream left. So the low will be 1,100. Okay, the high is anything higher than that. The highest number higher than that is infinity. We're going to use nines. Here we have 4 digits. So I'm going to go 6 nines. 999999. Mean doesn't change, 950. Standard deviation is 120. So now we just put it in, 1,100. High is just a bunch of nines. Same mean, same standard deviation. The P, we find out. We hit calculate. Okay, so about 10.56% or 0.1056. And that's the probability of running out. Okay, you may not be okay with that. Okay, are you okay if 10% of the time you actually run out and you're gonna have to tell people, sorry, we're out of ice cream. You can't buy here. Go somewhere else, go to the other ice cream store. Okay, it's probably not okay as a business person. Do you agree? All right, so what if you wanted to be 99% certain you're not going to run out of ice cream? How much do you need to have in stock at the beginning of the day? Okay, so same idea. We're going to need a low and a high, a mean, standard deviation, and a P. Okay, so we want to say how much do you need to have in stock at the beginning of the day so there's 99% chance that you don't run out. Okay, what's the lowest demand for not running out? What's the lowest amount that you could sell and still not run out? Any thoughts? If you don't know, I can tell you 0. If you don't sell anything, you don't run out of ice cream, right? If nobody comes to your store, you're not going to run out. Is that clear? Okay. The high, that's what we want to make sure that happens. That's what we don't know. Is that clear? Because we want to find out how much ice cream we need to have so we don't run out. That's the unknown. So we leave that one blank. Mean is still 950. Standard deviation is still 120. P now will be 0.99. Because that's the probability of not running out. Any questions on that? So now we just go to the calculator. The low is 0. The high is the unknown. Leave it blank. And the P is 0.99. That's the probability. And they calculate. And you get 1,229.16. So keep 1,229.16 ounces of ice cream in stock at the beginning of the day, and you'll have a 99% chance that you won't run out. Any questions? Any questions on this application? This business application? All right. So what I want to do now is tell you the secret word. The secret word is sigma, because sigma, that's the standard deviation. And to really, do these calculations and this stuff that we've just been doing, if you don't know sigma, you can't do it. So I figured I'd put something in there. So SIGMA, that's the standard deviation. And that's the Greek letter for standard deviation, but we're writing it in English letters, SIGMA. And that's the secret word for the day. So hopefully you understand the normal distribution. The shape of it's important. If you want to find out if the shape is normal, and let's say for your project, how do you decide if you have a normal distribution? What can you use? For your project? Because that's something you're going to have to do, by the way. Because you're going to have to decide whether you can use the empirical rule, and if you can, you use it. If not, use Chebyshev's theorem. How do you decide if you have a normal distribution? Any thoughts? Something we've already learned. You jumping in. You look at the histogram. And if the histogram looks kind of this shape, doesn't have to be perfect, but if it kind of looks like this shape with kind of a high point towards the middle, and then going down from there, it can, wave a little bit, but then you have an approximately normal distribution, and you can use the empirical rule. And you should on the project if you have one. If you don't, then you can't use the empirical rule, and you go to plan B, which is never as good as plan A. But if you can't use the empirical rule, you can't. And plan B is Chebyshev's theorem. So again, you're going to be doing that when you're writing up your project. So make sure you put that in your, in your project. So that's about it for today. Again, we're a little earlier than usual, and I warned you about that. Again, you have a lot to do this week. You have a project to really, really work on. You have your exam, week 4 exam. So again, the chapter stuff is pretty easy, but exams are always, important. And I want to remind you, week 4 exam will be more focused on chapters 4, 5, and 6, but it will have some stuff on chapters 1, 2, and 3. So that's kind of how it works. It's going to be some, like 25% or so on 1, 2, and 3, and the rest on 4, 5, and 6 in terms of points. So you do have to know everything, but if you don't know chapters 4, 5, and 6, you're screwed. Okay, make sure you know the wording that I told you to use so you can use that on the exam. and be able to do all that stuff. So I am going to stop the recording.